Slim, thank you very much for the raid. Welcome in everyone. I'm literally just getting started right now. Oh, don't do this to me. Don't do this to me, YouTube chat. Hey Rex, hope you're doing well. Oh wait, you guys can't hear the music. Bruh. 1 second. I'm gonna switch my scene. You won't see anything for a second. Okay, now you can hear the music. Why now? Why is this other thing happening? Hello, darkness, my old friend. So on Friday, I had to completely remake my OBS nearly from scratch, like all my scenes and audio sources and everything. It was a huge pain. And I probably messed something up, including that Spotify thing and probably other things. The thing I'm trying to figure out right now is I can see my YouTube chat, but for some reason I can't type. And I can't figure out... I think I'm not signed in, but I don't remember how I do that. God damn it. Okay, is there... Okay. I have a stupid idea. Sorry, I need a minute to troubleshoot this. Is it that? No. Is it that? No. Is it this? No. Is it this? No. Ah, what is my password? It was that one. I just typed it wrong. Do I not have her? Oh my god. 123 password. Hunter 2. Are you making me do this right now, Google? I really don't want to do this right now. Okay, you're not I'm not giving you my home address, Google. Why? You don't need my home address. Why would you ask me for that? Okay. Wait. What? Okay, I don't know why it's doing that, but hopefully this is good enough. Let me try and get my chat set back up. Damn it. It didn't work. I need to... Oh my god, dude. What is... I don't need to create channel. Wait. Oh, I know what I did wrong. Ah. No. Ah, wait. I signed into the wrong YouTube account. Fucking hell. Oh, you know what, Obi? I can make you a command too. By Ed Sheeran's beard. Hey, mouse. Oh yeah. Obi, I can make you a command. I just... I need to figure out how to unfuck my OBS right now. Okay, how do I sign out of this account now? Okay, can I just go to YouTube? So okay, yes. Sign out. Use another account. Please tell me it's this password. Okay, now you're making me do two-step verification. That is fair enough. That's not the YouTube app. That's not a wife. Yes, it's me. Yeah. You do not need my home address, Google. Stop asking. Okay, finally, I can actually type in my own YouTube chat now. Test. Okay, good. Sorry for the holdup. Um, yeah, I'm using the RTMP plugin for OBS. Yeah, that's true, Slim. They do already know. Okay. Now, there's a really easy command I can think of to make for OB. I promise I'll actually do math at some point today. Command triggered. Twitch, chat, send message. Hello there. There we go. What is that address? I won't show it on stream, but oh, Dukes of Hazzard filming location. Okay, yeah, that's me. Okay, I finally have it set up. I think. You know, I'm gonna play a. Did the stream alert? Did the audio play? Let me test it. Okay, yes, it's playing. Do you mean Denise? Son of a bitch. I bet. Yes, Lem, I hope your stream went well. Ugh. Um. Yeah, I think today will be a differential equation type of day. You can do reduction of order for repeated roots? Joseph with the first. I know you can do reduction of order when you have like y double prime and y prime. Oh god, I need to. My activity feed it got reset too. Channel points and redemptions. I don't need in my activity feed. I raid his neighbor's farms wearing his mask. Why? Oh, Spielberg's. Okay, that's what you're talking about. I want to review. I'm speaking slowly to buy myself time. Laplace transforms, systems, stability, like locally linear stuff. Oh, they have PDEs in this book? Hell yeah. I'll probably want to do PDEs too. I just a little bit of them. I just want to see what this section is about, because I don't think I knew you could do repeated reduction of order with repeated roots. Oh, that's where the T comes from? Oh, okay, I have seen this before. I just forgot about it. But I think this is the justification for why with repeated roots, you just kind of slap a t in front of your y2 solution. Yeah, like I guess that t right there. Because the way I learned it, I just memorized that you should do that. Just a lot of my differential equations knowledge, just memorization. Okay, this makes sense. It's probably worth it for me to go through and actually do this calculation at some point, but I can see the idea. Hey, Vera Mala? Yeah, freeze. Dude, it was so funny to hear you whenever you got hit by a freeze. You have a doubt? What's up, Vera Mala? Let's be linearly independent, so you need to accelerate the polynomial in front of the e term by 1 degree. It's an interesting way of thinking about it. I've heard that linear independent idea before, and it sort of makes sense, but I don't know enough about like what the vectors are, I guess, or like I haven't done linear algebra through that lens, I guess, so I don't feel like I fully understand it or slightly understand it. Talk with pen, yeah, fair. Because like I know that you can talk about linear algebra with like polynomials and stuff like that, but I've never done anything with that. Talk through the hand. Hilbert matrix. I have never learned those. If Hilbert's name is in it, it's probably pretty difficult though. Is my guess. Oh, actually, that's okay. That could be worse. Entries being unit fractions following this formula. So these are, it's symmetric, and these are the denominators. Huh. You can define them. Why would you want to define them with an integral when you already have this up here? Why are these interesting? A Cauchy matrix? Henkel matrix? The determinant of the Hilbert matrix is the reciprocal of an integer. So the determinant is also a unit fraction? What kind of messed up formula is that, dude? Oh my god. So yeah, Virmal, I don't know what you want to do with this. Oh, 1 second, guys. I meant to have this done before the stream, but I'm baking bread and I think it's done. I'll be back in 1 second. Here. 1 second. Ooh. I made some focaccia. It's not picking up super well, but um Ritesh, if this question, you can try me. I can't promise I can do it. Hey, Aditya. I think the film Matrix should have a sequel where the real world they live in is another Matrix. It's a nested Matrix all the way down. Yeah, maybe. Up close food. Break bread with us. The only toppings are olive oil, salt, and like Italian seasoning mix. But honestly, that's all I need. I want to take it out of the pan, and then I can relax. Actually, does it need to rest first? No, I think I does it? I think I wait 5 minutes. No, I think I do it now. 1 second. Wormhole to Chile on FA. I'll be back in a second. I just want to take it out. Okay. Whew. Uh, so yeah, Veermal, when it comes to Hilbert matrices, I don't know what to tell you. I haven't seen these before. They don't seem that complicated, but I don't know what to do with them. Oh, a JE question. Yeah, it's a JE advanced, Ritesh. Mains? There's a good chance that I can do it then. Feel free to post it, and the worst thing I say is no. Oh yeah, they didn't have a, or someone just said they just learned about this. I never heard of these, but yeah. Matrix makes zero sense to me. I think I'll never understand this. Uh, they are a little weird. I'm kind of curious, like what part of them don't make sense. It's the minimum of I comma j. It looks a lot like this, just flipped, right then? Hey, Pure Knight. Hey, Fembucks. Sign Patrol. So yeah, Ritesh, if you're able, type it out there in YouTube chat, or if you want to post a screenshot, put it in the Discord. With some equation, ax equals b mod m. Given a, b, m values as input, we have to get x values in output. Oh, yeah, you're right. They do say that exactly. Oh, yeah, you'd have, yeah, never mind, I see. It'd be like all ones across the top in the side. Never mind. I haven't done that mod M, Viramal. I'm not sure how you do that. Is that like a matrix equation? I haven't done anything matrix with mod M. FA Rubik's Cube and Mean Machine Rex wants a T-Rex. All right, let's do the Rubik's Cube first. Oh wait, I don't have. Wait, add existing. I fucking. How do I do this? I forgot. I didn't add Firefox back to the scene. I put it there. I'll put that there. All right, we'll scramble it. I'm not gonna do the scramble algorithm on screen right now. I'm just gonna scramble it. Yeah, Viramala, I don't know. I don't know how you do that mod M. I'm sorry. All right, scrambled enough. We get inspection time. Okay. Ah, shit. Ah! If I didn't hit space, or if I didn't miss hitting space, I would have been 24 point something, but it's not a bad solve. I made a few mistakes, but nothing to sneeze at. How be really bored in high school with nothing better to do and just practice it over and over again. Oh, so this is the inverse of the matrix you found. Wow, that is interesting. I know Viramala. I still don't know how to do what you're asking though. Okay. Now Rex wants a T-Rex. Oh man, how did I get a blank white before? Paper background, paper color. Oh yeah, and this is where there's a million shades of white. We'll do that shade. Oh no, this is a depressing, no. This is a really depressing, like, shade of white. It's more towards gray. Well, this one. That's better. Okay, a T-Rex. You know, I was not cheating to pull up a reference. Which one do I... We have so many options for reference pictures. Well, why do they have bulges there? Both of those have bulges there. Like, why? That one has a bulge too. They all have bulges. Did they just have bulges and I never noticed that? Also, that one is wearing a Christmas sweater. Could we have domesticated a T-Rex? Sort of how they breathe it in the dino suit? That is a good question. I like this T-Rex. He's a little bit chubby. I'm gonna draw it from a different angle though. It's probably dangerous. Okay. I do kind of like how that has like jowls, too. Uh, you know, I don't know why I bothered bringing up a reference because I'm just gonna mess it up anyway. There's no saving what I'm about to do here. I'm about to start on a master's in, oh my god, a month and a half. Viramala. Looks like that looks more like a bear paw. Um, hey, color cone. It was great, as always. The hands are very tiny, Rex. Yeah. So far, I guess you have no hands, but that will be fixed soon. Oh, by the way, guys, Color Cone is streaming. He's streamed at least twice now. So go follow him, hang out. I'm always terrible about remembering to shout people out. Some twofers. We need an I. No longer automatic for writing you. Good. That's huge progress. Where you're now allowed to say the word you in his chat, which you previously weren't allowed. Tiny little hands. I don't know. I guess you can have some ground to stand on too. That's helpful, right? Do you want to breathe fire too? I don't think T-Rexes do that, but you could. Yes, okay. On it. All right. I don't know. You're so magical. You are. This is truly magical. Oh, Slim drew one also. Let's show off Slim's too. We'll put it up on the fridge. Oh, the sunglasses is a nice touch. Not bad. Oh yeah, I can see that boxer. Yeah. All right, post this in the Discord. Oh, I just saw you post what the Hilbert matrix problem is. Um, hey, Hamudi. Yes. Uh, we're a little distracted right now, but we are about to switch back now that we've gone through our redeems. Thank you, big internet stuff. How to learn proving at math, just a lot of practice. There's dedicated like proof books, but they're not always like the most helpful thing. Draw myself, I have done that. Wait to get 2K again. Naman, people on Twitch can make you draw stuff. And so that's what was just happening. I was drawing a T-Rex. So prove the inverse is all integer entries. We're probably gonna look at the physics question first, because I think it's gonna take less time. And then we'll think a little bit about this problem. I can't promise that I can do it, but a long straight wire of radius A carries a current distributed uniformly over its cross-section. The ratio of the magnetic fields due to the wire at a distance A/3 in 2A. Ooh. Magnetic field of a wire. Isn't that like linear with distance, or just like inverse? It's just a power of it's just like 1/r, right? Hey, Sakano. I need to verify this. Magnetic field of a wire. This is a good website. I've definitely seen this website before. Yeah, this baby. I think Fenvox, this is one that Fenvox calls Bill, because you can write as like BI/L or something. Oh wait, I'm sorry. I wasn't showing the screen that I meant to. But yeah. Mu I over 2 pi r. Ritesh, you put something involving sine theta 1, sine theta 2. I haven't seen that version. I don't know what it would be. I don't think we'll need it. Trying to. So I'll do this out the long way, but you could do this a lot quicker if you know kind of the right way to think about this. Mu naught I over 2 pi. The first one is a distance A over wait. This is a trick question. Well, it's trickier than I thought. A over 3 is inside of the radius. Is the magnetic field inside a wire the same as the magnetic field outside a wire? I feel like it's probably not. Bill and Joe, yep. Magnetic brothers, electromagnetic brothers. Got all the combinations for approval voting. Use that for rated voting as well. I just need to see how I can make different series. Nice. Sock now. That's awesome. Magnetic field is uniform. I feel like it is actually still the same inside of a wire. I feel like I need to verify that. So I feel like Ampere's law doesn't really care. Saying different? Oh, you know, I is less. Is that? Yeah, I think I is less. It's only enclosing a third of the. Ooh, wait. We have to go by area. So A over 3 and A. The little A over 3 circle is pi A over 3 squared. So it's actually 1/9 the area of the big A circle. So we're only enclosing 1/9 of the current in the A over 3 thing. And then the R is still A over 3. So let's I guess let's shuffle these numbers around. I think it's just a 1/3 that comes out front. Because 1/9, and then this 3 gets flipped up to the numerator. So yeah. And then B2 is a bit more straightforward. Mu naught I over 2 pi times 2a. So we end up with just a half. Okay, and so now if they want B1 divided by B2, these two things here cancel. So we get 1/3 over 1/2. So 2/3? I guess the answer is 1? Inside the field increases the distance, outside it decreases. The ratio at 1/3 radius and twice the radius is 2/3. Okay, so we got to the same place. Shug, there is 590 Mossberg Mariner. Yeah, you're right. I should have gotten that right, Shug. Yeah, Namana, it's funny that it happens to be the right answer still. All right, that's a pretty. That question was trickier than I thought it'd be, but I'm glad we figured it out. You know, I would love if that was actually the answer to one of these questions one day. I've had an actual idea for a while to try and like do some math with like the random shotgun spreads in Daisy. It's really hard to find in the code where they do that, and if I can't figure out how they do like the randomness, it's hard to like do much. But it'd be cool to try and figure that out. Um, I'm from America. So 2020, 2019 means was on steroids. Oh, really? He famished meth and math. It can be both. I think the Wikipedia article probably does this for us, but let's not cheat. At least not yet. You're not disrupting, Shug. You're always welcome. So that's the 5x5 example. You do need coffee and energy drinks for math, so it's a good combo. True, yeah. um, prove the inverse matrix has all integer entries. I mean, so my immediate idea is have you ever seen the technique to get an inverse matrix where I'll do it for like 3x3s. The I'm so bad at thinking of random numbers. But just like say that is your 3x3 matrix. If you want to invert it, you do an augmented matrix like that, and then you do row operations on this. Like, I think about the logistics of doing this, and you can always just multiply a row through to get rid of all like the, maybe I should have just used the actual matrix. I was trying to avoid it in case it was potentially confusing, but I think it's actually less confusing. Like you can always multiply each of these rows through by the LCM. So you can multiply that row down there through by, I guess, 60? Is there a smaller one? I don't think so. You were in the Matrix last evening. What do you need to know? You only think you were, yeah. Taking the red pill or the blue pill? Um, you know what? No, there's more work to do than just this. But the general idea for this technique to find an inverse is you take the matrix that you're interested in. In this case, I took the 3x3 Hilbert. You augment it with the identity matrix, and then you do row operations until you have the identity matrix over here, and then whatever's left over here is your inverse. So it kind of like switches places. It starts with H3 and I, and then you do row operations, and you'll get I and H3 inverse. Whatever the inverse is there. So that's where my mind was going at first for something to think about for this, but it you need to do more work to show that you're only going to end up with integers here, I think, because there's still potential to end up with weird fractions without doing more work. Maybe let's do it for a 2x2 because that's a simpler case and just see. Just kind of see what happens. So that's I. We'll do h2 here. 1/1/2. This might be too small. We'll just go with it though. So I'm gonna multiply this row through by 6. That's not really necessary. I guess let's just go straight for the throat. Let's subtract off 1/2 times R1. Zero. So this is 1/3 minus 1/4, which is a 12th. So like this 1/2, we're gonna need to we need to hope it turns into an integer. That's kind of the work that would need to be done for this idea. If I see your name pop up in Twitch, I'll say some dumb shit. Are we savvy? You can say all the dumb shit you want. I love saying dumb shit. Just before I was drawing a T-Rex because I have a redeem where people can make me draw stuff, and you know, we like to like mess around here. Like a true mathematician, there's still some work to be done. Proof left to the reader. I mean, I haven't left it an exercise to the reader yet. So, like, I guess the thing you'd want to show here is that, because like we're about to multiply this row through by 12. You would need to somehow assure yourself that whatever number you multiply through by here is going to get rid of this fraction. And that should always be true. I don't know how you justify that generally, though. Thank you, Shug. Let's follow this work through to see if we can get any insight. 0, 1, minus 6, 12. Now we're going to take row 2, subtract off a half. Sorry, row 1 and subtract off a half of row 2. 1, 0. 1 plus 3 is 4. See, and this is another instance where you need to make sure you only have an integer. All right, so theoretically, I just found h2 inverse by hand. Assuming I didn't make a mistake. It seems right, though. It's symmetric. But yeah, so I was avoiding looking at this because it felt like cheating, but I think they proved this. Oh. Huh. That, yeah, how do you get this? They don't explain that. It makes sense a formula like this exists, though. I can imagine why one would. I sure haven't, collar cone. I forget what adjugate is. A joint. Not a blunt, but a joint. Um... The transpose of the cofactor matrix. Okay, yes, I know what that means. um, well, now why is the adjoint helpful? A inverse is equal to the inverse of the determinant of A times the adjoint of A. That seems like a helpful fact to have, maybe. The determinant of a Hilbert matrix is we said this before. It's an integer. Oh. It's some type of fraction, I guess. I don't know how you would use adjoints. There probably is a way. You'd have to say something about the cofactors and say something about the determinant, obviously. This formula is messing with my mind. Is this like a nested factorial? Or like it's like, yeah, it's like a factorial. It's like a double factorial, but not like an actual double factorial, not like the even odd factorial. It's 1 factorial times 2 factorial times 3 factorial times 4 factorial. I just want to confirm that Arrow's theorem doesn't work with cardinal systems, even though Arrow said it himself. Out of skepticism. But by me actually experimenting with it, with profiles just like Arrow did, if I come up with empty, then I believe this is a valid system. If I come up that there is the same invisible dictator, then I can say that we need to look at Gibbert's theorem and again work with that as a measure. Gibbert's theorem I have not heard of. Gibbert's theorem. Process is dictatorial. Which isn't a dictator how I would think of it. The process limits the possible outcomes to 2 options only. The process is not straightforward. The optimal ballot for a voter requires strategic voting. I guess I'm not sure what you're doing with the profiles with Arrow's theorem. I can see how Gibbert's theorem might be related. All right, I think this is officially a Googler. It's the exact question that we were asking about. Oh, wait, without it. Wait. Oh, you know, you can do row operations. I wonder if I should. Well, like, I'm not going to understand this answer. Also, this is a math overflow, which means you know this is serious. Trick or treats with the Hilbert matrix. Saying there's less choice for the person choosing in general if it can be attached to both methods and it allows for understanding what the problem is in choosing. Okay. Come on, load. Oh, I just realized. Ugh. There we go. I hide the URL of the browser that I use because if I use Excalibur, I don't want people to be able to just like type in the URL and jump in. This link just does not want to load. Freely available online, by the way. This is more than 10 years ago, though. Which is weird to think about. I don't quite know what you're saying, Suck now with like if it can be attached to both methods. I don't know what it is, and I don't know what the methods are, I guess. Okay, you know what, Viramala, I'm sorry, but I think I'm calling on this question. I don't know. I can't find anything that I think I'm going to understand anytime soon. This is just a little bit too much to actually do, so sorry. Whole semester to solve. All right. Well, good luck. It seems like there's plenty of resources on Google if you just look around for yourself. It's just a little bit more than I want to like look into on stream right now. Yeah, good luck. Okay, now I don't know what a cardinal or ordinal system is. I think it's gonna be a rabbit hole though of like I just don't know the vocabulary, and each time I look up one word, there's another word that I don't know. So I don't know. I feel like I just don't have the background for this. MVC. I don't know what MVC is. Yeah, sorry. Suck no. Should we do Laplace transforms? I kind of feel like doing systems more than Laplace transforms. Oh, multivariable calculus. It's not a textbook, but I do like this website, Paul's Online Notes. They have a section on multivariable calculus in the Calc 3. And then another resource, I'm sure there will be one. In the open textbook library, it has free and legal. Why isn't it opening? Textbooks that are actually like university level and used in universities. The site might be down right now. I promise it does work and I have downloaded books off it. But there's definitely going to be a few options for calculus there. That's a good email. Yeah, I don't know why it's not loading for me right now, but I'll just look at that website and pull a calculus book from there. Sure. Let's just at least skim this section here. How do you get good at math? I'll let you know when I'm good at math. The only thing you can do is just practice. There's no way around it. The Kevin paper is the political science side on one side. Political science on one side and the math on the other side, like a side-by-side translation between scholarly papers. I don't know that they're the same thing though, or that they can translate like that. Bad parenting game? No. What is W? Is that Wronskian? Wronskian. I feel like I've heard of Abel's theorem in a different context. Oh, this is just unrelated. Okay. I was wondering if this was a specific version of the same theorem, but it's just a different theorem. Well, I feel like if that translation exists at SockNet, it would mean they're really the same field. I should look back and learn about the significance of the Wronskian. I know how to calculate it. At least I knew how to calculate it. I don't remember, like, I don't know why it would be important here. Or the Wronskian being identically zero or never vanishing means. Yeah, I'm from California. Hey, Sage. I hope your vacation was good. Okay, let's actually, no, a diagonal matrix is too easy, right? You visited California, it's a crazy good place. Oh, nice. It's not perfect, but I like it here. You're still getting adjusted to NYC. Ooh, Europe is so different architecturally, demographically, but man, I miss eating meat. Same thing, they're vegan, so the alternative was hard. Ooh, wow. That's funny. I'll see you later, Sage. Thanks for saying hi. Very costly, for sure. Yeah. Everything's more expensive here. All right, so let's just solve this for a little bit of practice. Let's see if I remember how. I haven't looked at this in a long time. So I don't really like. Well, do I like it? How would I do it? I guess I like that. I don't really know if I do. I don't know. Um, the thing I just wanted to remind myself of is that this x vector, it's like some x1 of t, some x2 of t. I guess I just wanted to remember like what was inside each of these vectors, and I think that's a but yeah, the procedure for solving these that I should we'll just solve it first. You basically find the determinant of this matrix. I'm sorry, you find the eigenvalues and eigenvectors. Um, uh, 1 minus 2 lambda plus lambda squared minus 4. So lambda squared minus 2 lambda minus 3. You set it equal to 0. So we get lambda minus 3, lambda plus 1 is 0. Now we need to find each of the eigenvectors. So when lambda equals 3, minus 2, 1, 4, minus 2, 0, 0. Solve this system of equations. Get that. Phi or phi, it looks like that for lowercase. Oh, you're talking about the golden ratio. It's like 1.61, I think you mean. Unless this is a different fee that you're talking about, but there is this fee here. Is that the one? I mean, maybe the phi could also represent a different constant. Constants does phi represent? I'm sure it means more than one thing. Oh, the Euler-Mascheroni constant? It's capital phi? No, wait, that's gamma. I love macaroni too. Hey, Teha? The system has a saddle point at the origin. Solutions move toward the origin in one direction, away in another. Probably. I haven't gotten that far yet, but that's a good guess. Well, welcome in. So yeah, the Euler's constant, which is a terrible name because of E, but that is 0.57. Maybe it sometimes is represented by phi also, by capital phi. I forget why it's the pi approximation tier list. What? Oh, these are approximations for pi. I get it now. Euler, yeah, it's kind of funny. That's kind of a funny one. They're just saying phi though. They're not saying. They probably mean the golden ratio. We can check that, I guess. ln of ln. That is okay. Yeah. At 6:45. Why would you say that's an I guess anything's approximation for pi. Oh, they also have E there. What games do I play? My favorite game that I'm playing right now is Daisy. I'm working on a seafood playthrough that I need to pick back up. Factorio is also a favorite that I need to get back to at some point. But there's also just like some random games I like to organize. So I just got like a Mage Arena lobby together with friends on Saturday. So Daisy plus a variety, basically. In engineering, E is actually not equal to pi because E is electron. True, yeah. His first name sounds better. Leonard's a cool name, yeah. Computer file? No, not really. I actually watch very little math YouTube in general, to be honest. Oh, this is the dreaded Kasai. Ugh. Disgusting. If x1 is 1, x2 is positive 2. Oh yeah, Ted, well you said it's gonna be right because we have one positive eigenvalue, one negative eigenvalue. We can already tell. It, it does, the way that I drew it does look like a thunderbolt, yeah. It's not really supposed to be. This shouldn't happen. These are independent. They're supposed to be dependent. Oh, it's -1. It's -1. It's -1. It's -1. It's -1. It's -1. Okay. Math still works. Wait. What? Ah, so it's +2. So if x1 is 1, x2 is -2. Is that a point of the origin? Yeah. Okay, so then okay, well before I do that, let's write out the solution. So x of t is, our first eigenvalue is 3. Our eigenvector is 1, 2. So 1, 2 e to the 3t. Yes. 1 minus 2 e to the minus t. And then the phase portrait you know, I never really questioned it. What are the axes here? Is it x1 and x2? I think it should be. I'm a little bit unclear on that. I'll have to look at the answer. But I know how it should look, which is basically draw the vector 1, 2 and all its multiples. Something like that. And e to the 3t is increasing with time, so it's oriented away from the origin. And then we draw 1 minus 2. And it's negative power, so it's going towards the origin. And then some example solutions off of these eigenvectors basically kind of follow the flow of what we just drew. Depending on our initial conditions. Something like that. Let's see what the book says. It is x1 and x2. It looks like I got it about right from that phase portrait. But let's look at the actual answer. That's how Kasai should look. Why are they doing superscripts? I noticed that they do superscripts, and I don't like it. 1, 2. Oh, I forgot my constants. Oh, rookie mistake. Unbelievable. Take off half my points here. All right, and so it is, yeah. So this one I don't feel the urge to solve. This one is going to be a sink from looking at the phase portrait. Because we have two negative eigenvalues is the important part for that. I know there is one thing. What are our eigenvectors? 1 root 2 minus root 2, 1. Minus root 2 and 1 has an R2 of minus 4. Minus root 2 comma 1. So okay, yeah, so there's an important trend in this phase portrait, which is, you know, I should just draw on this. 1 second. I really wish they drew in the eigenvectors. Because it's an important bit about this phase portrait here. One of our eigenvectors is along there. The other one is it? Wait. Really? The other one, I think it's something along here. The thing that I want to think about is this eigenvector here has a much stronger pull. Like the arrows are way more influenced by this eigenvector than by the other one. That's because the eigenvalue, but the eigenvalues are flipped from what I thought they would be. This one right here, competitive programming, I have heard of it. I don't know very much about it. I'm just looking at the eigenvalues now, Zach. So with 1 comma root 2, the eigenvalue is minus 1. So I wonder if the roles are flipped for negative eigenvalues. The other eigenvalue is minus 4, and I thought the higher absolute value was the more influential one. But maybe I have that flipped when things are negative. The other eigenvector is minus root 2, 1 with an eigenvalue of minus 4. Maybe I'm just crazy. E to the minus t is greater than e to the minus 4t. I need to see that on Desmos for positive t. Right. Okay. But then if things were positive, the reverse would be true. That's okay, yeah. So when things are negative, you have to flip your thinking. You want the smaller one. Okay. But yeah, so I guess the point is that when these two eigenvalues or when you're somewhere like around here, the closer you are to the origin, the bigger the influence this eigenvector in particular has compared to the other one. Ooh, that's a lot to look at. What do they do a three-dimensional one? I remember doing these, and it would take we'd have to get phase portraits for three-dimensional ones also, and trying to get the perspective right, because MATLAB can do 3D phase portraits. I'm sure Python can too. Trying to get the perspective right to take a picture with is a pain. They are, Zach. Victier, thank you for the follow. Okay, so this will be a fun one. Now we're into complex eigenvalues. So let's actually solve this one. Spirals and circles. Mm-hmm. Okay. So first things first, eigenvalues. Oh my god. I said it and I didn't do it. In typical me fashion. I wonder if there's anything like, do symmetric matrices have a certain type of solution? Their eigenvectors are perpendicular, right? I don't know if that's important or not. I was kind of curious if any of the terms I learned about in linear algebra are significant, like symmetric matrices or I don't know. I can't think of another interesting one. No, I know this one in particular isn't symmetric. I'm just wondering in general if you had a symmetric matrix, if that would have like some type of interesting property in this context. And I guess perpendicular eigenvalues is something, but I don't know if that's all that important. Is that really how that multiplies out? I guess it is. I feel like this looks stupid for some reason. -1 plus or minus root 1 minus... Oh, hey, they kind of engineered that to work out nicely. If you have a symmetric matrix that's diagonalizable over the real numbers... Right. And so I was wondering, like, if that would be, like, in a physical system, if that would kind of have any special meaning, but I guess it kind of depends on the system. Um, these are always a pain in the ass to solve. Can I just know that these are dependent and not worry about doing actual row reductions here? Because I remember always doing the row reductions, but is it even necessary? Can't I just know that as long as I did the prior steps correctly, these are going to be dependent and I can just worry about the first row? Because I really hate solving systems like this. Yeah, Fembox, I'm reviewing systems. So Kasai 1. If x1 is 1, x2 is I? Now I feel like it's a trick. Doesn't like Kasai 2 always looks a certain way. I can't remember what it is though. Don't you just make one of the signs negative or something? Like you can choose whichever one you want and you just make that one. I guess we'll verify it. But I'm pretty sure that it always follows a pattern, and we'll just, for Kasai 2, we'll just like slap a negative sign on that or something. It's gonna be I1, 1, it's gonna be like that, our system. Yeah, and so we do just slap a negative. Conjugate. Okay, okay. That makes sense. Cease, or I don't, Kasai, it's P? In what language? Oh my god, terrible. In Portuguese? Oh, that's funny. Oh wait. Did I make a mistake? No, I'm okay. Well, I might have made a mistake, but I remember cheating and seeing the phase portrait in advance, and I thought it was just a rotation, but it's actually a spiral, so I'm okay. All right, good night, mouse. If your initial matrix is real, then eigenvectors come in pairs of conjugates. Okay. Cheating? Yep. I'm just a cheater. I love cheating. Don't forget the constants this time. We split this up into a real and imaginary. Okay, yeah, so these ones are a bit more of a pain in the ass. A lot about this is a pain in the ass, to be honest. Because we're gonna have the answer right here, but I think it's common practice to split this up into a real and imaginary part. Cheat at anything but not your GF or BF. True, true. If you see a mouse that isn't poisoned, it's not the best. Okay, so now we need our old friend Leonard Euler, or Euler, someone from Boston might say. Cosine t plus I sine t plus c2 1 minus I e to the minus 1 half t cosine t minus I sine t. Squeeze it in there. Now we want a real part and we want an imaginary part. I think. So it'll be C1. Ugh, I need to multiply this out. I feel like there's just an end formula that you can just know for this. This I is going to come inside the vector. I think is what we want to do. I might be doing a whole lot of nothing right now. I don't think it sounds that bad. Your mind goes places. Same. And so I think now that the idea is that that's 1, 0 plus 0i. I think we do that type of thing. But that means like this is kind of it's kind of a lot. Yeah, I just noticed that when you said it. And save. If I do split up the vectors like that, what happens again? I'm trying to play this out in my head. Skeleton, the 9 months Twitch baby. Thank you so much, baby on the way. I hope you're doing well, Skeleton. I appreciate you. You just want to see some math. You're like 2 weeks without math? Get this man some math stat. Hey, Optimus. Besides 1 or 2 puzzles? Oh, nice. I mean, right now I'm not doing part of math that I don't think you enjoy it. I'm just trying to review differential equations. Earlier, we had this kind of funky Hilbert matrix problem that I couldn't do. Got an exam for fluid mechanics soon. Oh god, good luck. Are you like a graduate student? Vector from statistics or combinatorics? Honestly, I don't associate vectors with either of those, although I'm sure they come up. The vector that I'm doing comes from differential equations, but really comes from like just kind of general linear algebra, not a particular application. And so this could represent a whole bunch of like physical things. The one that I like the most is like the first entry of each vector could be the population of some animal that's the prey, and the second entry could be the population of some animal that's the predator. But there's also applications like physics. and stuff like that too. So I don't know what they all are, but they do exist. You'll officially be a mathematician in 4 months or so. Oh, well, like you're graduating? That's awesome. Yeah, Lacca Volterra. It's when linear algebra is just taken over math. It kind of does. It's just it's everywhere. Although I feel like we mostly studied linear differential equations because we can use linear algebra and it's pretty helpful. Like the nonlinear ones are just kind of impossible usually. I feel like I'm getting into the weeds with these manipulations. I kind of want to check if I'm doing the right thing. Oh yeah, I do want to remember how to do that. Because I remember you can use like locally linear systems for nonlinear equations. This is one of the last things that I learned about for my degree, and I've forgotten kind of everything about it. I still have my old exams, and I remember looking through them like a year ago or something. It's being like, I did this? I don't remember any of it. Everyone's remembering what divergence does to different stuff like scalar, vector, tensors. Oh, yeah. Fair. Undergrad mechanical engineering. Okay. An exam for fluid mechanics, there's so many equations you gotta memorize. Dude, I bet. Especially as an engineer, they make you like memorize stuff rather than just like derive it. Gotta decide what to do in grad school. You suppose you'll just choose a professor and see how it goes instead of selecting a very specific subject. Yeah, I mean, that's kind of my attitude. Like, I think I don't know enough math yet to be able to choose a very specific topic. So I kind of want to like, learn more and then choose. Even deriving it is too much. Oh, yeah, it can probably be a huge pain. I have a problem. I forgot to get to fill my water bottle before I streamed. Math attacks can be forgotten and remembered. Like, how can that be stopped? I wish it could be. It's such a pain. I used to know the stuff here. I've learned about PDEs before, and I forgot about them. I've seen the work of me solving PDEs, and I forgot everything about it. As far as I know, you can only stop it by practicing. But if you don't use it, you definitely lose it. It's much easier and faster than when you see it the first time. That's true too. You definitely pick it back up a lot faster. Professor you're thinking of are either topologists or algebraic geometers. Ooh, nice. Colorcone, are you an algebraic geometer person? I feel like I've seen you say that, but I honestly like once it gets to that level of math, I don't know what anything is. So I have a hard time telling for myself. I had PDs last year. I forgot what you're supposed to do. Yeah, I remember how to do the heat equation now because of Zach's class on series. Which when I say Zach, I mean e to the 2i pi. He taught an infinite series class at the start of end of last year, start of this year, and that included the heat equation. So I remember how to do that now, but everything else, like the wave equation, I've forgotten. But yes, Skeleton, if you didn't know, Color Cone streams now. He like just started. So if you want someone to talk to about algebraic geometry, your soul is bounded to algebraic geometry. That's awesome. Even graduates also have issues with mathematics. I see that sucks on a huge scale. Like it always becomes a memory game. So the nice thing about math is that if you're like theoretically all stuff that I forgot, if I can just like I could go back to the fundamentals and probably figure it out again from scratch because I've seen it before. I just need to like unlock the memory. But yeah, you kind of like need references a lot of the times. Only mathematics I can get behind is numerics and solving stuff numerically. That's fair. For certain types of problems, that's all we can do. I had the pleasure to suck at every topic in math because algebraic geometry forced you to learn so many subjects. Kind of makes more sense than sometimes solving differential equations a certain way because someone told you it works that way. Yeah, like especially for differential equations, numerical solutions are great. It's all like they always work. I mean, maybe not quickly, but solving them analytically can be terrible, and solving them numerically can be pretty straightforward. I tried to read some algebraic geometry, but for fun, got humbled real quick. I would be too. I'm more comfortable with algebraic topology, but I don't think that helps. Yeah, I need to be a bit better about shouting people out in general. That's the general list of like math streamers that I can like recommend. I did just recently expand it, so it's up to 2 whole messages now. But yeah, so the math niche on Twitch is growing. Fluid mechanics. um Unfortunately, no. I'm thinking. I think fluid mechanics is a gap though. Seeing stream some problem solving stuff, mostly real analysis. I'm TAing it. I like to solve a bunch of problems for the students. Oh, nice. I know that you used to stream. I remember like watching you play chess a bit. Well, oh, first follower dibs. Got it. Reading some chess flick on stream. Yeah, I remember that. I remember you be like you have like an addiction problem with chess. So screening stuff on YouTube is different from your book. Oh no, this drives them talking about Bernoulli equation. Oh, that sucks. Honestly, I did just notice that Merriweather is missing from my list. I should probably go and add him. Let me do that before I forget. So here. Oh, I have to. Okay, you know, I don't want to do this right now. The way I have this set up. Uh, add Merriweather to list. Don't bring down the curse of Mary. Wait, is there a curse for not shouting out Merriweather? Or is there a curse for doing it? Either way, that he's good with like electrical and engineering stuff. And math in general. King Alfonso X of Spain has a whole book dedicated to the game of chess. I did not know that. How modern was he? King Alfonso X. In the 1200s. Dang. Actually, yeah, I wonder if the Wikipedia article mentioned it. Chess. Oh, hey. Libro de ajedrez, dados y tablas. I wonder if they have the actual PDF posted. Ah. Oh well. Some nice Catholic songs too. Oh, nice. Commissioned or co-authored? Oh wait, is this like a puzzle? Why is it sideways? What a terrible format. I can't tell what anything is. Wait, he created the Spanish language? What did they speak before? Tong is Bay. Small thing to add to your... Yeah, I created Spanish, medieval Latin. I guess that makes sense. I don't think of a language as just like one person inventing, though. I feel like it kind of naturally develops. I guess that doesn't have to be true. I guess I'm thinking of how like Mandarin was like simplified. I don't know. Let's see what this song is. So easy, my brain was just better. Same. That's fair. Yeah. I feel like I'm playing Baldur's Gate 3 right now. You know, for this type of music, it's not bad. I have Mouse is already asleep. Mentored with scholarship at Toledo University. Surrounding forced the nation to adopt the language. Oh, interesting. I have no idea how to pronounce it. Camões is sometimes credited with the invention of Portuguese because the books were the standard for good Portuguese. Oh. Interesting. Man, this playlist is so average. I need to find a new playlist to mix things up with. This is a new playlist, but it's all the same songs, I feel like. I don't know what to listen to, though. You know what? Okay, I could do radio for this song. A Terraria slash yerba mate playlist. Oh my god. I feel like you need some real hard electronic music to match that caffeination. What was I doing? Oh yeah, I was checking my work. So I was getting annoyed at having to do all these manipulations. I'll add that song in. Is that from the new album? There's Marks of the Evil one. Is there also Marks of the Chosen one? Evil? Okay, okay. I put it in queue. Actually, you know what? The song, it's funny, but it's not that good. Okay. Oh, that's what you do. Wait. You only need to care about one of them? Seven 7.4.5. How do we know these are all the solutions, though? B1 proof sleep. I don't blame you. I used to play old school RuneScape. I played it a good amount when I was a kid. And I've had a couple of times as an adult where I've started it, but I don't usually end up sticking with it. Like I sometimes have a craving for a game like that, but the grind just isn't worth it. And I'll read that comment in a second. Sock now. My question was, so they claim that, I guess they only say a pair of real, so that they're only taking one of the complex valued solutions to the system. Sorry, I feel like the music is too loud for me trying to actually explain this. They took only one of the solutions for the differential equation that's complex valued. That one solution they split up into a real part and imaginary part. And they said now those parts individually are a pair of solutions. But do we get different solutions from the other? Like x2? Maybe it's worth working out both of them and seeing if they match. There'll be a linear combination of those two. Okay. Interesting. Started last week. 50 attack, strength, and prayer already? I mean, the attack and strength I guess you get from like rock crabs or something. You don't have to actually do it, but or you don't have to actually like, be there, but that's pretty impressive to have that already. But yeah, it sucks in all of your time. And the really discouraging thing is that if you work it out, so levels in RuneScape go from 1 to 99, but the way that XP works is exponential. And so you can spend a shitload of time just getting to level like 80 or something. But the halfway point between 1 and 99 is actually at level 92. So you're not even halfway there. Yeah. And so after hearing that fact, like, man, it's just not worth it to get to 99. I think. Sakano said earlier, kings can do that sort of thing to force linguistics on the people during the medieval period. Like, I love him, the king, as a person, but I hate his politics and hated what he did. Something I don't support from those days. Great from the culture, yes, in certain aspects, not good in others. Yeah, that is kind of a... Like, it seems like a messed up thing to do, at least. The Four Horsemen inspires some fantastic art over the year, I bet. It wasn't just good for language. It was literally creating the language so that they can unify the people away from invading countries. Politics, remember the medieval times were highly divided, and the degradation of land was to capitalize on this idea of new empire. Huh, cool. Uniqueness of solutions. Yeah, I guess so. I didn't know that these would be all. Like, I didn't know why there couldn't be others, but I guess there's not. Have I heard of permutations of tensors? I'd never learned anything about tensors, so no. From 30 prayer to 62. You reach 43 for the all the protection stuff. Fair. What am I doing? Suna, hello. That is an adorable emote. You're just lurking. I hope you enjoy the lurk. I appreciate you. Okay, so then the real part of this is, I guess we'll put it all into the vector. Okay. And so theoretically, these are the pairs of solutions, or this is the pair of solutions. Let me verify that. Cosine minus sine. Sine, cosine. Yes. But now I want to see, like, what if we do this with x2? Once you find two solutions, you know you're done. Oh, that's a good way of thinking about it, I guess. I still feel the urge to see it for myself here. But that's a good point. I heard of it, but don't really understand it, especially because one of assumptions here is isotropic fluid, so it makes permutation of one tensor correspond to a different tensor. In short, pain. I'm feeling tensor already. Huh. Yeah, that sounds complicated. Okay, so the thing I want to think about is, does it make sense that these two things are more or less the same? I think they're exactly the same. Besides the -1 constant, which is fine. Okay, that makes sense. Portuguese was a whole other thing. Yeah, it had Andalusia, more interlocking communities because of their reactions towards the Kingdom of Castile and Leon. Sign of regional pride that later grew into Portuguese becoming a nation. Fair enough. You want to get back into math, but I'm so lazy. Fair, fair. If you want to like just like be able to think about math without having to do anything for yourself, I can definitely recommend like math YouTube. People like Veritasium or 3 Blue 1 Brown. That might help like scratch that itch if you want to, but also fair enough if not. Hey Skirtle. Looking good, thank you, thank you. No effort math, is that a thing? I mean, the thing about like math YouTube is that you don't have to write anything down for yourself. You just kind of follow along with their logic. So it's at least a lot lower effort. Yeah, passive learning. No effort math was until college. For me, it was until my last year of high school when I took my first calculus class. I remember at the start of the semester spending about 2 weeks just pounding derivatives into my head, trying to figure out what they mean. Eventually it clicked, and then the rest of it went pretty smoothly. Okay, I want some water, and I didn't refill before I started the stream, so I'm going to be right back. I'm just going to leave the screen up, though. Um, MIT Open Courseware, yeah, I'd say that's a bit more. If you want to engage with it, it's a bit more active, but it's pretty. You don't have to engage with it, I guess. What branch of math am I good at or have knowledge of? Oh my god. So my background is I have a bachelor's in applied math with a minor in computer science. The things I'm best with are like calculus and below. But and once you get beyond calculus, I do know things still, but it gets like more and more spotty. I'm pretty good with differential equations, linear algebra. I'm already running out of things to mention. um, I know some like physics. I've been studying that. Mechanics and E&M. Yeah, after that it gets real spotty. Like a little bit of number theory and combinatorics and stuff like that. A tiny bit of abstract algebra. But that type of math, I haven't. I've been like barely introduced to them, I would say. Basically, linear momentum conservation equation for fluid mechanics. Oh yeah, for Optimus and Hamiltonian. You want to learn astrophysics? I would love to learn astrophysics too. I think it'd be a really interesting thing to learn. I believe I've seen Obi or N Simplex Pachinko doing some of that in his stream. Like I think I've seen that at least. Or doing some type of like space math. Well, will this open textbook website work now? I wonder if they have one on astrophysics. Hey, it's working now. I wonder if they have one. Might be down in physics. Pleasure, technology, and star. What? Come on, there's got to be astrophysics somewhere. Yeah, it is kind of sus. Ooh, I'd be interested in this book. Come on, there has to be an astrophysics one. Oh, I'd be interested in this book too. Hey, there's a fluid mechanics one. Coastal dynamics, that could be cool. Huh. I want to be. I'd be curious to like flip through the pages and see what type of math they're doing. Oh, this one too. What is this? Dude, how do you not? There has to be an astrophysics book somewhere in here. I refuse. Apparently not. Oh well. I don't know then. I'm sure there's gotta be some resources somewhere for astrophysics. If I wasn't gonna start grad school soon, like it's a thing I was thinking I'd be interested in like reading about or doing like a reading group on astrophysics or astronomy in general. I am in the more statistics and social choice and game theories, right? You wish to get into combinatorics, right? You know what, Optimus? I think I'm okay. I didn't realize there was an astronomy section. Fluid dynamics would be a cool thing to get into at some point. I might have to do it for part of my degree. I'll definitely have the option to do it. Oh, come on. Are you just not going to load now? Why is this website not working half the time? Come on. Load. Go faster. I'm getting bored. Oh well. It was nice to look at the website while it lasted, I guess. Okay, the other thing I want to think about this with this problem. Wait, was I answering a question I just... No. Oh yeah, well, what type of math am I good at? I think I answered that. Yeah, astrophysics would be awesome. Like, learning about how orbits work, stuff like that. So what's the intuition for... Okay, so... Like, but the next thing I'm wondering is why this pair of solutions produces a spiral. So first off, it's spiraling inward because we have the negative in the exponential. And if it was just sine and cosine alone, I would expect it to produce circles, right? Maybe ellipses. You wish you had interest in stuff still? Oh, I'm sorry. Hey, why is it clockwise? It's like a thing orbiting something losing energy over time. Yeah, true. Why are you clockwise? Pray tell. So huh. At a single convenient point, right? If you choose x equals that, ax is that. So the point 0, 1, x prime is 1 minus 1/2. Okay. I understand why that's clockwise then. Okay. That makes sense. What is this? Oh, wow. You found some books. Thank you. All this looks cool. Wow, it's only 250 pages, but there's all these chapters. Holy crap. Yeah, this looks really cool. Thank you for finding these, Sock now. All right, Optimus, sleep well. Good luck with your fluid dynamics. It's cool until you have to understand it. Yeah, probably. Well, I just be studying this for fun, so if it ever becomes not fun, I could just stop. This is a good song. Wait. I thought it said dark gluon, and I was like, the dark gluon. Deuterium bottleneck? That sounds sick. It sounds like something out of a sci-fi novel. How can gravity become repulsive? I don't know, it can say something really rude to you. Wait, there's a genes theory? What is... Does that have to do with Levi genes? A Poisson equation? Oh man, we got the delta stuff. Oh god. This is pretty heavy into the math, which isn't a bad thing. Adiabatic perturbations? That sounds like a heart condition or something. Okay, you know, I just wanted to see what genes theory is. It's clear they don't want to tell me because I refuse to do more than skim it. But that's funny. Important thing is to go with the flow. True. Any topic is like a jug of water, don't drown yourself. That's true, yeah. Okay, I don't think we need to do... Well, example 2 could be cool because we're doing it a more general. Okay, let's think about 2. I do want to get into non-homogeneous systems as well, because I don't remember those at all. Okay, eigenvalues. So lambda is alpha plus or minus root alpha squared minus 16 over 2. Okay, so the thing to pay attention to is the discriminant. It's just reminding, like, when someone is just learning how to solve quadratic equations for the first time, they ask why this is a useful thing. and like this right here is y, because it becomes a very small part of a much bigger problem. But it's really hard to explain that to someone who's just learning this for the first time, because this is way too deep. um So we have like kind of critical alpha points at plus and minus 4. So if alpha, if the absolute value of alpha is more than 4, we'll have distinct real roots. Can we go further and say something about the sign of those roots? Like, can we solve the equation alpha is greater than root alpha squared minus 16? Because that would mean both are positive, both roots. If you square each side of an inequality, I think that means you need to consider two separate inequalities. Oh, well, this is already... No. Why isn't this working? Or is it working? 0 is always more than negative 16? Are they always positive? Desmos can answer this question. Our old buddy Desmos. Hello, Desmos, my old friend. I've come to speak with you again. So theoretically, if alpha's greater than 4, we always get positive roots. Oh. Should that be obvious because of the y-intercept? Yes. I can understand that now. So then what about negatives? Same behavior, but over there. Interesting. Okay. Alpha equals 4. Or minus 4. My handwriting is so bad. Papadoria, your brother wrote his first really short text about math. Would you be open to just reading and seeing if there's any room for ambiguity or something unclear? He doesn't want you to read it? Okay, yeah, sure. I'll read it. He doesn't trust you to give good feedback. It's funny. I think in the complex case, we can still say something about the sign of the real part. Don't use your page in Wikipedia. I do not use Wikipedia that much. We use that because that's where a LaTeX editor was. If I send the link to my user page, will someone else be able to view it? I mean, if you were to put in like Discord, then yeah. YouTube chat, you can't put links. Do you want me to like not do this on stream? Like I can do it off stream and let you know. If you want, you can like send me a DM on Discord, I guess. Just send me the link and I can write you a message back. Is YouTube chat still in slow mode? People have been okay for a while. I could take that off. I'm trying to figure out how to get it off slow mode. If you want to keep it private, you could like message it to me, but you could also just post it in the Discord too if you don't care. There's slow mode. All right, I'm taking slow mode off. Hopefully people don't make me regret it. Okay, so I'm willing to like read this now on stream and talk about it as I'm reading it. Is that okay, or would you rather me not do it on stream? Oh my god, there's a lot happening here. Yeah, I should believe it then? Okay. Okay, I might not be able to read through all of this, but let's at least... It also looks kind of complicated. But let's see like how much we can do at least. This is Papadoria over in the YouTube chat, and Papadoria is known for giving very difficult problems. In this case, this is a paper that his brother wrote, and his brother is looking for feedback. Just read the numerical approximation. Okay. Cosine of x is about minus 1 to the alpha times f of x minus alpha pi. Oh, okay. Oh. And explain further. Okay, yeah, because I definitely they seem a little out of left field. Every 1 or 2 integer solutions for alpha. And it's usually 1. Okay. Uh, is the shift what's causing this restricted definition? Or is the sign approximation only valid in a certain interval in the first place? Okay, that comes from the sign approximation. And Lux, I see your question. I want to read through this first. But Lux, if you can tell me if I'm writing your problem down right, I can do your problem after. It's basically take the derivative with respect to x for inverse sine. Is it 6x minus 4 root 1 minus 4x squared over 5? Is it like that? The whole thing is divided by 5? Okay. So yeah, I can do that. It's gonna take some doing, but I can. I'm gonna read through this little paper here first, though. If you're not able to stick around, me solving it will be in the recording, though. Your cosine x about 1 minus 1 half x squared. The guy sheet tells you not to worry about. Ugh. Yeah, like the. I assume it's a better approximation. It's a very strange looking one though. But yeah, okay, so this domain for the approximation definitely seems like enough to use symmetry. Seems like a good idea. Um, in this domain, we need to flip the sign though, right? Are we can? I assume that's just we're okay with that, or like that's not important. He gets to that part later. Okay, okay. The pattern of odd integer multiples of pi being our boundaries in an integer offset of pi can be generalized in the following way. Sure. Okay, yeah. So here's where we worry about the negative bit. Okay. Okay, so I guess I can understand like that bit there now. I'm just believing that this is what the f of x should be. Hey, Selenia, it's going good. How about you? This answer is intended to hold as long as one can find a suitable integer value alpha that shifts the input into the domain of the original approximation function f of x. Well, this interval has a length of pi, does it not? Okay, so okay. So in response to your other question, I think just like a simple like like right here in parentheses, you could just say like, and negated or something. That'll probably be enough for me there. Step 7 clears it up. I guess so. I'm a little tripped up by the x over pi part, but that interval is definitely length 1, I guess, because it's an absolute value less than or equal to 1/2. Yeah. I yeah, it's like it's just x over pi is just a number. I still like, I don't know. I just had to like get past that, I guess. Um when x over pi is equal to n plus a half, where n is some integer. So that's basically saying that alpha minus n plus a half less than or equal to a half has 2 integer solutions for alpha. Why is that? Maybe it's easier, like, should I just look at 1/2 exactly? Well, that's not, maybe like, the integer solutions here would be oh wait, no, maybe just 1/2. Alpha could equal 0 or alpha could equal 1. Is the point there? And then if we did have 1 plus a half, I guess you can finagle something. Okay. I think cosine of x is about 2 minus cos x. Oh no, you can't divide or you can't factor out. No. Oh my god, syntax. So basically what we're doing right now is Papadori in the YouTube chat his brother wrote a little paper that is this numerical approximations section here, and he's asked me to like read through and give any feedback. And so his brother wrote about this numerical approximation for cosine. And so I'm just trying to like understand it and give any feedback. I feel like that's a thing that you think is rad. I just look at it and go like, what the hell? Oh, okay, so the point is that you can line this up, maybe, so it goes perfectly on two integers. Well, it's a little bit weird to do with this, but there are two integer solutions for every C. Yeah, it's posted in the Discord too, but it's there, and then specifically the numerical approximation section. And if you do have any thoughts, feel free to post some, oops. Either here in the Twitch chat or Papadoria, like, this is where he posted it here in math discussion. You named it Hello Dawn? the Desmos. Hello. Yeah, that's what I was trying to figure out there. Like, I wasn't seeing it. And don't we want, I feel like we want this to be, then the interval is length 1? Oh, okay. Yeah. Okay. Fair. Sign approximation proves very similar, so I feel like you can skip to the special cases part. Wait, I'm still thinking this doesn't address what exactly you do for the two integer solution case. I assume you can just kind of choose one? Or maybe it's just like a weakness of the approximation that it's not clear which one you choose. Or maybe maybe that's discussed down here. Doesn't matter which one a person can choose. Should tell them that to mention. Okay. If x is a rational multiple of pi, then the approximation looks like this. I guess it's just kind of shuffling around the denominator. Oh, okay, yeah. We get to mention it there too then, because that's the first time it comes up. All right, so getting common denominator. Okay, that's kind of a nice formula right there. Yeah, okay, that kind of makes sense. At if you plug in values of pi, you should get kind of nice things back out. This is where we evaluate the forms we got for cosine and sine previously. You have the following. Sure. So the integer solution for alpha here is 0. Twenty over 73. Yeah, that is kind of weird. Like that's pretty dang close for being such like a small fraction. Because even though pi is like a nice number to plug in for sine and cosine, it's still irrational. Usually. It can be. There's like the 1/2s and the ones, but hmm. Uh Let me clarify your places where you were lost. As long as I have to believe, just kind of believe certain things when it comes to the how the function looks in the interval. So if I ignore that, I think it's pretty good. Um, I I imagine it might not be that hard to to do it numerically, I'd be kind of interested to see if you could find where the error is maximum. See, I think you could just take like cosine of x minus the approximation, take the derivative, set it equal to 0. Yeah, you'd almost certainly have to do it numerically. It might not be an interesting number in that case. I guess like a maximum and a minimum error could be interesting. I think I understood the big idea of it, which is kind of taking this existing approximation and shuffling it around to extend it for the entire domain. And that introduces this weirdness with alpha. Okay. So green is approximation. Red is true. Wow, that's amazingly close. What the hell? Zoom and enhance. Okay. Oh well, does it transition from being under to over? It does. Where do they intersect? Is there something special there? It's probably just a random number. Oh wait, if cosine is 1/2, that's pi over 6, right? That's kind of interesting. Wait, no, that can't be pi over 6 though. Oh no, it's pi over 3, I'm sorry. It's pi over 3. They happen to exactly match there. I guess so. That's a nice little illustration of it. And obviously outside the domain it goes crazy. You increase A, then you can zoom out. See, the black approximation sort of zip the cosine function. Oh. That's a cool, like, visual. Like, you could make some art with this. Like, this makes you want to make like a loading screen icon in Desmos. You know, where you have like a spinning circle. Can you just do A equals floor pi over x plus a half. That's from ooh. Equals 4 pi over x plus a half. Need the absolute IV to be as small as possible. Okay. Yeah, I was trying to figure out if this was too complicated for the interval. I didn't know what else to suggest though, so thank you for the suggestion. There's syntax. There's no doubt he'll believe my feedback as it comes down from not me but you. Yeah, you know. Overall, I think it's pretty understandable. And I think using the floor idea is probably going to be make it a little bit easier to follow. So I'm definitely I still feel a little bit uncomfortable with the integer solution stuff. So I feel like I just need to like go through it by hand a lot before I feel like I really had a good grasp on it. But yeah, no worries. Thanks for the question. Yeah, it seems like a pretty good one. Trying to derive the actual f of x on his own, so he's planning to put a derivation of x in his text too. Oh, nice. With a new iteration or two? God damn. I mean, I think it's okay because he's citing a source for it, but I definitely don't understand like anything about where it comes from. Yeah, like a link would definitely be helpful. The Desmos link is really good too. Yeah. What was I doing before this? Oh shoot, we need to answer Lux's question now. I'm gonna type at Lux in the YouTube chat, so it makes it easier for them to find it in the recording. So, Lux asked this question before, and I put it on pause. I think it's time to do it now. If he gets his own derivation of it, then I'll make sure to tell him to put it in there. So he's like, the reader's also exploring it. Okay, yeah. No worries. Could it be f of x be a second order Pade approximation centered at pi or at 0? I'd never heard of Pade. Heard of Padme. It could be. It is a rational function. It's like Taylor series, but rational, pun intended. Oh, funny. Oh yeah, it does kind of look like that. Interesting. Looking for e to the x, you want to take large negative numbers. Ooh, okay. Okay, so this derivative is pretty annoying. Let me just verify that I'm gonna derivative of arcsin. Okay, yeah, so the derivative of, if we had just arcsin or inverse sine, if it was just of x, it would be 1 over root 1 minus x squared. Now, when we have the derivative of inverse sine of something like that, we take this entire thing and insert it here for that x. So this is going to get real messy real quick. Squared. So that's the first part, but now we need chain rule. So we need to take the derivative of the inside function here as well. So the derivative of 6x over 5 is just 6 over 5 minus 4 over 5 times the derivative of this. So we times 1 over 2 root 1 minus 4x squared. Oops. And then chain rule again on the inside of that radical. We'll get times minus 8x. Looking at the page for the Bhaskara guide, as I mentioned, its equivalence with cosines at a approximate. I'm curious to see how close they are. Yeah, that'd be an interesting thing to find. Instead of bringing up to negative positive infinity, it goes to 0. Okay. And so technically this here is the answer. I'll clean it up a little bit, but this is a very painful thing to try to simplify. Like, this is just a mean question to give to a student that they really shouldn't be giving. 6 over 5 plus 32x. We can make that 16. And so honestly, I would just leave it here. I don't think it's worth doing anything else with this. Hey, Nebu Nebu. So, and I'll plug into Wolfram Alpha just to verify that even if you did go through the painful part of trying to simplify that, you're probably not going to get much out of it. I'm just typing this in quickly. So yeah, if you try real hard, you can make it look like that. If you want to call that simpler, be my guest. It doesn't really look all that simpler to me though. Do you know that arcsin can be expressed with logs with complex number inputs? Yes. It is also true for arcsine and for arccosine. There's a way that you can derive them too. I forget the trick. Might be in chapter 2. I bet it's in this section here. Yeah, here. So if you want to figure out the formula for inverse cosine, you do the old switch the variable trick, I guess. And then it's quadratic equation in e to the iw. Right. Then you just take the log of each side. Yeah, that's not that bad. That question got a little mangled, Nebu Nebu. I'm sorry, I don't know what you're asking. And Pav asking, I guess, nearly the same question. That doesn't seem like the entire question. If you have this, we can definitely just apply the quadratic formula. Alpha less than 1 less than beta, then the true set of values of lambda equals. Okay, so the question is, I need to rephrase this. I think this is what you're asking. Okay. Well, I guess we would take the smaller root goes with the negative, so alpha is less than 1 would mean that 3 minus root 9 minus 4 lambda over 2 is less than 1, and we could solve this for lambda in theory. But what do we get? That's kind of funny. So I multiplied this through by -1. If I squared each side, I might not have flipped the inequality. I think this is more correct, though. So it feels more correct. So meaning lambda is less than 2. Does that make sense? If I take lambda equals 0, I would get, it would satisfy that. Well, this isn't the entire answer. This is only part of the answer. So we need to consider that the other root is more than 1. So 3 plus root 9 minus 4 lambda over 2 is greater than 1. Only 6 works. Well, that's not good. But you did have to say a different version of the question with a 5. Nebu nebu. So maybe we're getting a different number for that reason. So I'm just going to square each side here and cross my fingers. Well, that's not good. Or is it good? It's correct? Okay. I'm just a tutor. I have a bachelor's in applied math. Huh, okay. Yeah, so basically the idea for the problem is we know how the roots must look from this equation here if we just use the quadratic formula. So that was the first thing to set up. the next thing to realize is that this piece of information gives us another constraint. So the root that's smaller, or like, we know that this inequality tells us that alpha is less than beta. And so that means alpha must go with the root that goes with the minus sign. And beta must be the root with the positive sign. And so that's why I set up the inequality. That's why I know that alpha being less than 1 means that the smaller root with the minus sign should also be less than 1. And so I set up this inequality and I just solved it for lambda. And then I did the same thing here with beta, but with the positive root. And funny enough, you just get the same like thing both times, so you don't need to change anything. I was expecting it to be like, one to be like lambda less than 2, and the other one lambda greater than 1 or something. And then you just have like an interval. But apparently not. Thanks for the follow-up, Pav. No worries. So Nebu Nebu did ask a similar looking but different question. You can try to think about that one too. This one looks a little bit harder though. Okay, so I guess that's the question that Nebu Nebu is asking. Spoiler is that the answer is 6. J previous year? Oh. Probably can't do it. Actually, I have no clue how we use this equation to our advantage. I mean, it is a sum of 2 cubes. I don't see how that helps us, though. Like, my only thought is to look for similarities between... Is this how this factors? Yeah. Look for similarities between this and whatever difference of 2 cubes, or sum of 2 cubes, would give. I forget how exactly it looks. Global clan, what is algebra? That's kind of a big question. I don't really know what you want to hear with that global clan. Like, if you're just being introduced to algebra for the first time, it's kind of the place where you learn how to manipulate equations, I guess. But there's a lot of possible answers to that question. I don't quite know what your context is. Oh, I guess. Do we equate coefficients? This must be the idea, right? We equate coefficients from here. And if p plus q is 5, I guess we can plug it in there. So really, if we can just sell this for PQ, we would be in business. K equals 6 by guessing. I think we have to square each side of this. So we can say p squared plus q squared is equal to 25 minus 2pq. So minus 3pq is equal to minus 18. Oh, wow. Look at that. 6 pops right out. And PQ equals K is the point. So K equals 6. So I guess this works. I just kind of... I don't know, just kind of like fumbled around until I happened to get something, I guess. All right, see you, Nebu Nebu. This kind of is a good place for me to call it for the day, honestly. I'm getting hungry. So yeah, I think we will. That was the wrong scene. This is the right scene. We are not just about to start. Okay, but yeah, that's gonna do it for me. People here on YouTube, thanks for being here. Plan to be back on YouTube on Thursday.